Were you tweeting again?
It's what I do.
I know it is what you do.
I'm a Twitter girl. It's a problem. I love
Uh,
Google Plus, but Twitter
Star
just
Strider on Twitter with a Y,
with a Y. I
and I'm
should put
F
up my lower
Kane
third.
on Twitter.
Yes, you are.
You put up your lower third. Yeah, who are you? Again, who is this person?
It's all a mystery. A mystery, I tell you.
So I guess the third and final act of our trilogy, Weekly Space Hangout, Astronomy Cast, ends in fiery death with the Chelyabinsk meteor. Actually, no fiery death because nobody died. Ends in exploding fireworks with the Chelyabinsk. So
Fiery
shattered
roof
glass,
flaps.
shattered glass, I guess, is how it ends.
There was a roof
Um,
collapse.
was there a roof
hmm
collapse?
hmm
Hmm.
Not exactly fiery, more like, but
Yeah. So once again, oh, did I remember to click on the Q&A app? No,
do we need to restart?
I
Can you
did turn
still
on the
turn?
Q&A app.
Okay.
Whoa, and people are already using it, so it's all working. Okay. And people have been asking their questions again. That's great. Thank you very much, everybody. Um, if someone could have any astronomer from history in the virtual star party, who would you choose? I would choose Galileo. Can you imagine showing Galileo stuff in the virtual star party, like showing
It would
him?
turn into a total Bill and Ted's excellent
Oh,
adventure.
that would be so great. Great question, though. Wow. Um, we'll answer that one again at the end of the show. Okay, so for those of you who just joined us, who maybe missed the first part of this, we are going to be recording a live episode of Astronomy Cast. This is going to be episode 334, Chelyabinsk, 1 year later. So we are recording this on February 7th, but this is the show that we would normally record on February 10th, Monday, and it would go live on our feed on February 17th. Monday, which is the closest we get to Chelyabinsk. So this is how we have to think into the future. We have to plan these things out like a careful orchestra of celestial objects. So, can you tell I've had 4 cups of coffee and three shows? Getting a
That's
little
all right. I
punchy.
apparently had like the best typo ever.
Did you?
Uh, Fergus Mason on Twitter points out that instead of writing Chelyabinsk, I wrote Chelyabink, which
Chely.
just leads to the idea of a meteor hitting and going bink.
Thomas, I have updated my calendar. That's what he was trying to get at. I didn't know what he was talking about. He's like, Fraser, it's February now. I'm like, what have I done? I have not updated my calendar. Look what's going on here in my year in space calendar. We've got Sarah Horst.
Oh,
Isn't that
awesome.
great? And we've
Sarah's
got,
a great human.
I know, and so this is great. The world of Titan. So, year in space, 2014 calendar for February. I am slow on the uptake today. So,
It's okay.
um, Q&A app is on, so if you want to ask any questions, you can use the Q&A app. We will stick around at the end and answer some questions. I don't know how your time is. Um,
I'm doing okay.
okay. At some point, I will have to be a parent, but, whatever. Lord of the Flies. um, okay. I think I'm ready here. You ready there?
I know your children. It's more like Jungle Book.
Yeah. So say
Yeah,
when.
I'm good. I'm pressing record.
I am also pressing record.
Hi, Preston.
Hello, Preston! Once again, we thank you for your dedication to Astronomy Cast. Here we go. Astronomy Cast, episode 334, Chelyabinsk, 1 year later. Welcome to Astronomy Cast, our weekly fact-based journey through the cosmos. We help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville, and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing?
Getting a little crazy, actually. Now that
You are over
I am
caffeinated,
over
and
caffeinated. It's true.
I'm recovering from the flu, so we're a great pair today.
Right. Although it sounds like it's been week after week that you've been getting your astronomy cast just like normal, we're actually recording 2 of them today, just after we recorded the Weekly Space Hangout. So yeah, so it's It's a very high energy. I'm pretty jazzed up. Is there any other announcements? Anything interesting to talk about?
Just a reminder, we have all the apps. There's a 365 Days of Astronomy app. There's an Astronomy Cast app. There's a Universe Today Phases of the Moon app. There are count them two, but only available in Android, CosmoQuest apps. So if you want to support the shows and get something that you can go look and learn and have fun, go get apps, please. Please.
Go all the apps. Download all the apps. Cool. And then I just want to remind people that we're making our videos on Universe Today, and they're available now on iTunes. So if you want to download the videos and have them show up on your mobile device at the time of your choosing and watch them, you can go to universetoday.com/video or universetoday.com/audio, and you can subscribe, or you can get them on iTunes as well. Cool. Well, let's get rocking. So around this time last year, a space rock crashed into the Earth above Chelyabinsk, Russia. It brightened the skies for hundreds of kilometers, broke windows, and injured many people. Let's look back at the event. What happened, and what did we learn? Can you believe it's been a year?
I know. It was one of those events where I was not quite at the dead of sleep stage, but at the I'm asleep and the bed is so warm stage, and my phone started going off, and I pick it up, and Nicole, noisy astronomer, Nicole Guglielmucci, was basically like, something happened in Russia, get on the internet right now, and that caused me to actually get out of my nice warm bed and go to my keyboard in the middle of the night, and it was unclear exactly what had happened, other than it was a very bright object that could not be denied, and YouTube videos were going up left and right. And I think the first thing that we learned is Russia has so many terrible drivers that everybody has dashboard cams.
Right. But so shortly after Nicole told you,
I called you.
You called me, and I think Phil called me as well. Like, there was like all of these phone calls going back and forth as we were notifying each other. Jason Major let me know as well. So it was the same thing. You know, I know you live 2 hours into the future, and I had sort of was just about ready to go to bed as well, and then my phone was going off, and so
we all watched
so much
it
for sleep. Time to go to work. And so we had to, sit down in front of the computer and get reporting and get updating and figure out what was going on.
Well, and the first question all of us had was, this was the same day that an asteroid was scheduled to make a very close approach, passing much closer than the moon, in fact, passing closer than geosynchronous satellites to the planet Earth. And so there was was there another object that's related? And so, of course, that was the first thing, and everyone's trying to figure out from the dashboard cams and where the sun is and all of that, what the directionality of the impact was, and people fairly quickly realized, no, completely unrelated object, completely different orbit, coming from a completely different direction, we're good. But so that was the neat thing, was how quickly we were able to start estimating what direction in the sky it came from, by looking at, it was early in the morning, could see the sun, had geographic landmarks, dashboard cams, street signs, street light cameras, and could watch the bink, 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 bink as it goes all across the city.
The Chelyabinsk. So can you then paint a picture, like if you were living in Russia, which you have done, and you were driving to work in the morning?
I wouldn't have done that.
What did they see?
So these poor sods were up early in the morning fighting with traffic. Were minding their own business when all of a sudden something brighter than the sun went streaking across the sky, and then went kablooey and caused a giant flash. And this was in a good-sized city, but kind of in the middle of nowhere, Russia. So out near the Ural Mountains. This is a factory city, and that's got to be somewhat freaky when you live in a country that, like the U.S., grew up under the fear of the Cold War. So you have all of these people suddenly seeing bright thing across sky, kablooey. And the problem was that as it went through the sky, it was initially going faster than the speed of sound. So there was the shock wave of the explosion and the sonic boom that traveled much slower than the speed of light. So you see move, 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 kablooey flash, and then pause, and then you get hit with the shock wave of the sonic boom. Now, for the drivers, they got to see the entire process or catch it out of a mirror or something like that. But to the poor souls who were still eating their breakfast or in a classroom or something else, nature had it out for them, because this is a Russian city. They didn't exactly use shatterproof glass to build your average apartment window. So people see giant flash. That's the type of thing that causes you to get up from the table and walk to the window and go, huh? And about the time they're getting to the window, the shock wave hits, and it pretty much shattered $33 million worth of glass in the city of Chelyabinsk.
Can you imagine, yeah, it's exactly right. That you be like in bed, you be at the kitchen table, whatever, and then suddenly your entire room would be lit up as if it was daylight. And so first thing, you're like, that's it, that's the bomb, it's the end of the world, here comes Armageddon. But
Yes.
You would probably walk over to the window to sort of figure out what it was that had gone on. You'd look up and you'd see this big plume in the sky, and you're like, huh, what is going on? And then seconds
that
later,
one of the awesome things is I speak very bad Russian, but it was enough that I could understand a fair amount of what was going on in the YouTube videos. And so you have these drivers, they're like, huh, that's odd, or that's weird. And they'd say it in a completely matter-of-fact voice. Very, well, it's another day. There's a flash in the sky. Gonna keep going. No big deal. No one's pulling over. No panic.
yeah.
People with cell phone cameras, you see them like, ooh, must get a better shot. But that's the Instagram mentality, not the world is ending mentality.
Yeah.
And so I just love that characteristic that is so different from what you'd get in the United States.
Right. And so you just imagine those poor people. They're walking over and they're staring up at this big cloud in the sky and they're trying to figure this out, and it's silent. Just completely silent, right?
And after the kablooey, there's just this beautiful contrail through the sky that's starting to get all squiggly as the wind moves it around. And then?
Yeah, and then, boom, this shockwave roars through and just explodes the window in everyone's faces. And was it 1,500 people went to the hospital with glass injury so severe that they had to go to the hospital, right? Like, you can imagine, again, these are tough Russians who just took a
wearing
plate glass window in their
clothing.
face. Yeah.
And
in the wintertime, yeah.
It's
in
one
Russia.
of those things that nature had it out for them. It was the perfect setup for a really painful joke. It was a Three Stooges episode, and we were one of the Stooges.
But amazingly, like, no one died. Nobody died. A Tunguska-level event happened over Russia, and nobody died, which is just amazing.
To put some perspective on the initial impactor, the thing that initially entered our atmosphere, it burned up, got smaller as it went through the atmosphere. The object, when it started to enter the atmosphere, is estimated to have been about the same mass as the Eiffel Tower. The chunk that they eventually were able to pull out as the largest piece, which landed in a lake, was still over 1,000 pounds.
Really? I didn't know they pulled up a chunk that big.
Yeah, and unfortunately, they set it on the scales to weigh it, and it tipped over the scales. Literally, it tipped the scales. And when it hit, this thing that had survived through the atmosphere broke into 3 pieces.
Wow.
Yeah.
So we've got this, on the morning of February, it was 15th.
15th.
Right? Yeah, February 15th, this object came from space, detonated in the upper atmosphere. How high up did it explode?
Sorry, Preston, you're going to have to edit the pause while I look this up.
I
You
didn't have the
asked
data
me a
in front of
number
me.
that I had it in front of me and then I looked away. Okay, sorry. Answering the question, you can now go back. Sorry, Preston. So we think that it probably exploded in the air at an altitude of about 97,000 feet or 18.4 miles or 30 kilometers. So this was about 3 times higher than your average commercial airliner flies at on the long haul flights. So it was high up in the atmosphere when it exploded. And that actually had one very neat consequence of it scattered shards over a huge area of land. And it was Russia in winter in the Ural Mountains. So this is a snowy place, and so there's lots of really neat stories of school children basically going out and looking at the surface of the snow for holes in the snow, and then digging down where the hole in the snow was to find the meteor shards. And as someone who grew up on the East Coast, that's how you can find clams, is you look for the air hole in the water, and then you dig down and there's a clam. Well, they used essentially the look for the hole in the snow. And if this had happened in summer, well, first of all, there would have been a lot more injuries because people wouldn't have been dressed as solidly, and I'm sure people with the flying glass got, in many cases, protected by their heavy winter clothing. But you wouldn't have been able to find nearly as many chunks of it because it would have just been harder if it hit dry land rather than penetrating through nice white snow.
Yeah, you think about that right now. Like, there are probably meteorites all around you, wherever you are. You just can't recognize them because they just look
Exactly.
like rocks.
And some meteorites, we don't think about this, but one of the really great posters I saw one year was from collecting meteorite fragments, and then they were comparing them to the size of rabbit herds in photographs. And so the meteorites were smaller than the little rabbit balls of poo. And that was the most fascinating thing to see on a science poster.
Right.
So there's
So,
small pieces of the universe all around you, and they're very hard to find.
yeah. Okay, so we've got this object, massive, the Eiffel Tower. How big was it then?
It was several kilometers across initially.
You want to answer that one again? Because I don't
I
think it was
got that.
several kilometers
No,
across.
you're right. It was several meters across.
Yeah.
Hold on. I was looking at how fast it
It's
was
the
moving.
size of Texas.
Yeah, 20 meters.
Okay.
Sorry. Yes. Sorry, Preston. This is going to be the episode where I get numbers wrong. We think that it was probably about 20 meters across initially, and of course it got smaller as it came down. It burnt up, so in some cases you have, as it passes through the atmosphere, the heat is literally melting the outer parts of it. It eventually exploded into small fragments, and those pieces went all over the place. In one case, it destroyed the roof of a factory building, so roughly a 600 square meter roof went flat, no more roof. And this happened in winter, and one of the biggest issues they had to deal with, this is all a lesson in all the things that can go wrong. This is a city that has central heating for the entire city, so they're pumping hot steam, hot water to all the buildings. And with all these windows blown out, you've had, with the freezing weather, problems with pipes freezing. We've had problems with pipes freezing here. Well, now you're looking at an entire city that shares the same heating system, thousands of windows blown out. And so the city got behind replacing all of the windows that went into people's apartments. They didn't replace like balcony windows that might have gotten broken.
Yeah.
But so it was a level of damage that we hadn't encountered, but it could have been so much worse.
Right, and so this is where I was going to go next, which was that you looked at Tunguska, and it was about the same sized object, wasn't it? Maybe Tunguska was a little bigger?
But it was a completely different type of event. There's a lot of people that think that Tunguska was probably a comet, or at least a more volatile, rich object that came down, because when it exploded, it leveled a massive area of Siberian forest. It's clear that the universe has it out, in particular for Russia. So when the Tunguska event occurred, there was this massive shock wave that flattened forests, and we didn't see that kind of a shock wave with the Chelyabinsk event. Now, the thing with the Chelyabinsk is it was basically a lumpy rock. This was a kind of rare kind of lumpy rock called an LL chondrite. This means that it was low on metals, it was low on iron, and this combination means that you're basically looking at the type of material that the crust of the Earth is made of. It had a lot of silicas. What metal it did have in it was ferrous oxides. Everything's formed together into, well, this is where the name comes from, chondrules of material that the minerals are bound together. But it's not a metallic object. It's a mineral of stuff that's all mixed together. And this lumpy chondrules of mineral in this big old rock is perfectly happy to fall apart, which gives us all of these different shards of meteorite. Had this been an iron-rich asteroid, that wouldn't have fallen apart in the atmosphere quite the same way. Had this been a comet or something else that was extremely volatile rich, the process of having all those gases sublimate would have caused a different kind of shock. So since it was a nice, friendly, low metal, low iron chondrite rock, this was about as low a harm event as we really could have asked for given its size. It also didn't come straight down.
Right, that was my next question I was going to ask, is like, what was the impact angle? How did it come in?
Well, so it swept across Russia. Nice, long, slow angle of impact. So if you look at one of the images of it, it spent a long time in the upper atmosphere. The long time that it spent in the upper atmosphere meant that it got slowed down a lot by the atmosphere. It's when stuff comes straight down and you don't have these nice, gentle impact angles that you end up with the energy not getting given off into the atmosphere, but instead it's able to plow much more deeply into the Earth. And
yeah, there's some wonderful simulations that I've seen of the Tunguska impact, and it's like this plume of energy that just came straight down like a hammer, and that's what flattened all the forests out from this impact zone. While with the Chelyabinsk,
right,
it was this low skimming impact, which I think was, again, we were really protected by the composition of the object and the impact angle.
It's still, all of this said, gave off 20 to 30 times the amount of energy of the nuclear bomb that exploded in Hiroshima. So it was a lot of energy, but it was a lot of energy given off in a long distance through our atmosphere rather than all in the impact. The explosion occurred up above airplane flying altitudes, and then it was just the chunks. And one of the really neat things that I read was the majority of the pieces were gravelly sized, and as they came down, they hit their terminal velocity. So since they were traveling at their personal terminal velocity, it was the same as dropping a piece of gravel off of a skyscraper. Sure, it's going fast, but it's not going as fast as that 1,000-pound block that luckily fell into a lake. That was going at about 60 to 70% the speed of sound.
Right.
So,
right. The rest of that raining rock down on everybody was not quite as damaging.
Right.
Yeah, it's interesting. So was it like shedding material as it was, like it detonated and was one big chunk that just kept going, or was that chunk ablating as it went through the atmosphere?
It's one of those things that we're probably going to be telling that story for a long time. People are going to have to go out, map out the full distribution of where all the meteor chunks were. There were a couple of unconfirmed, unfollowed up on reports of chunks that fell much further east of the main event, where, if they're to be believed, and I don't think they are since no one followed up on them and it's been a year, but if they were to be believed, there might have been some chunks that were given off in earlier eruptions than the final explosion, essentially, that left behind this one giant piece.
And on that day, the next day, all of humanity came together to seriously assess the asteroid threat and built a fleet of space missions that imaged all of the asteroids to tremendous detail and sent out teams of astronauts to start pushing astronauts into safe orbits to protect us from this terrible future.
No, in the years since then, we have seen cuts pretty much globally for the funding for astronomy, which means that coming up with ways to deter the threat, coming up with ways to discover these, is going to get harder and harder.
People got really busy, though. There was a lot of attention within like a week.
Yes.
And I know, like, our friends from the B612 Foundation and, a lot of other people were asked to speak and provide their expert advice.
Planetary resources.
Yeah, to share what kind of a threat this is. And I know there was sort of conversations on the Hill, and then let's take an axe to all the funding.
It's one of those things that kind of amazes me, because when it comes to our fear of terrorism, there seems to be no amount of money that they're unwilling to spend in order to try and prevent nail clippers from going onto airplanes.
Yeah. What about the war that the universe has started on us? Why are we funding against this war against the universe? Because it started it. It's throwing rocks at us. We need to fight back.
And this is one of those things that leaves me somewhat baffled, but it is what it is. So I can only ask that every time they increase the amount of imaging technology used on me and my baggage when we fly, they spend the same amount of money on imaging technology to protect us from rocks from space.
So there's a few things in the works, though. Like WISE just came back online.
Yes.
And it is searching. It's using for infrared objects, which asteroids definitely are in that category. And then there's the work on the NEOCAM, right, which is going to be another potential mission. There's the Sentinel mission, which is what the B612 Foundation is working on. There's stuff the Planetary Resources is doing.
Telescope.
Right. So there are a bunch of missions that are in the works, but we didn't see like a rise in funding. We didn't see any extra energy put into these things. If anything, the overall budgets have been cut back.
Right. So it's one of those things where I can't explain it. All I can do is sigh into my microphone.
Right. We heard it. It was a sigh heard around the world. So what's next then? I mean, they're going to be studying this rock for years, for decades. I mean, it's great. They got a huge chunk of space delivered.
Well, and what I also love is the entrepreneurial spirit that came up is almost immediately chunks of the Chelyabinsk meteor were available. You're looking for yours. I am,
yeah. Looking for mine.
Mine's unfortunately in my office on campus, where I can share it with students and go, here, it's cool. Thank you, Richard Drum. There, yes.
There's a rock. This isn't Chelyabinsk, though. This is. Can I buy one?
You actually have one sitting on my desk that I don't trust customs with that Richard Drum got for you.
Richard Drum got me a chunk of the Chelyabinsk meteor, and it's waiting on your desk for me. Why have I only just discovered this now?
Because I thought I told you, and apparently I forgot.
That is so cool. Richard Drum, thank you so much. I love you. Okay. That is so great. Richard Drum is the person who got me into meteorite fandom in the first place. So the fact that he's just continuing his habit is great.
He is the awesome individual that keeps our YouTube channel going and does all the audio editing for 365 Days of Astronomy. So when you donate to 365, you're helping me pay Richard to be awesome.
So how much does a piece of the Chelyabinsk meteor cost?
I don't know. Ask the internets.
Okay, internet, how much does it cost? I'll look it up on eBay. Of course you could buy them on eBay. That's amazing. Okay, so people are going to be studying these for years, right?
Yes, and this is one of those cases where I suspect that people are just going to be going out with metal detectors, and that's the awesome thing is even though it was a low metallicity, low iron meteorite, um, it is still more metal rich than your average piece of, say, granite. And this means that the way they were able to find that giant chunk in the bottom of the lake is, well, initially they actually sent in February in Russia emergency dive teams down to look for it. And when they looked at the bottom of the lake, they found nada. But that summer, a science team went down, surveyed the bottom of the lake using metal detectors, identified a large object using the metal detectors, and it had buried itself in the mud at the bottom of the lake.
Oh,
And
yeah,
that really
okay.
makes sense. If you've ever walked around in the lake, it does not have a completely solid bottom. And if something's going to hit at a fairly significant fraction of the speed of sound, it's not just going to rest tidily on the bottom. So they dug it up, brought it to the surface, tipped over the scales with it, broke it into 3 pieces. But the way they found it was with the metal detector. So people are going to be going out with metal detectors, collecting pieces, mapping out the distribution, figuring out just how far and wide were these things scattered.
So when will we see another one of these? How often, he says, well, Pamela coughs, how often will an object of this sort of size and mass and damage hit the planet?
And this is one of those things that we talked about some last week. We can't fully answer that question because we haven't fully mapped all of this size of object. There's an entire class of asteroids, the Apollo asteroids, that have Earth-crossing orbits. And it's just a matter of time before one of these orbits causes us and one of these Apollo asteroids to be in the same place at the same time. And when that happens, things go kablooey or bink, depending on what noise you choose to attribute to it. And so we're now looking at, we've seen Chelyabinsk, we've seen Tunguska every 100 years or so. We
Wow.
don't know, though. We previously been saying this was every few hundred years. The bigger things we're still looking at being every few million years or hundreds of millions of years, depending on how big you want to look. We're also overdue for one of those.
Yeah, I know. 65 million years ago, the last one hit, right? And it's time.
Yeah.
Universe.
Yeah.
All right. Well, I thanks a lot, Pamela. And it was amazing to sort of experience this whole story unfold with you and the rest of the space community. We all sort of had a chance to watch this whole thing unfold in a time of the internet, and it was quite an experience. And I hope it turns into the wake up call that we know it should be for the lawmakers and the funding agencies to try and get some of these things mapped out and searched out, and that would be great.
Yeah, I really think the idea of, I mean, it sounds lame, but it's a fairly reasonable argument. Let's spend the same amount of money looking for the things the universe is doing to try and kill us that we use to try and find ways to identify uh, other people who are trying to kill us. That would just be, I mean, imagine if we spent the same amount of money on astronomy and space science that we spend on TSA, that we spend on Border Patrol, that we spend on the FBI, on the CIA, all those organizations involved in protecting us from death. Um, let's look for death from the skies.
Together we can defeat the universe.
Yes, yes, we can.
All right, that I think that's a T-shirt. All right, thanks, Pamela. We'll see you
Thank
next
you.
week.
Okay, bye-bye. And stay tuned while we
Don't you go
pause.
anywhere.
We are simply saving, and then we will answer your questions with my froggy voice, which is so much better than it was a week ago.
Yeah.
A week ago, my voice was cracking and disappearing and imploding, and I had the flu. And now tiny intern on Twitter has the flu because I made the mistake of letting her borrow my gloves.
Right. The bloody gloves. Saving. Man, there is mayhem in this house right now. I can hear the children.
I can hear them.
Can you hear them? Yeah. I wonder how much
Yes.
that's going to make its way into the episode. All right. Good. I'm safe. You? Are you safe?
I am saved.
Okay. You've been saved. All right.
So yeah, our intern here at SIUE is at tinyintern on Twitter, and that just makes me happy.
Ooh, I just about filled my hard drive. I should clean that up. All right. But I'm sure that's very interesting to everybody watching. So let's remind you that if you want to ask Pamela some questions, either about what we talked about today or any talk about space and astronomy, like, for example, what is string theory? Why is there something and not nothing? What came before the Big Bang? Is time travel possible? Those kinds of questions, Pamela's glad to answer them. But until then, we'll get rolling. So Paul Stewart says, I get to watch Astronomy Cast while imaging the sun. My day can't get any better. Paul Stewart, if you aren't aware, is the upside-down astronomer who is imaging the sun right now from New Zealand, and don't walk, to check out his website. It is unbelievable.
He does amazing.
Yeah, he's often joins us at the virtual star party. Prominences on the sun, and the nighttime stuff too, but his daytime stuff is unbelievable. So, upside-down astronomer, Paul Stewart. Check out his stuff. Tom Nathy says we need to see this alleged Preston. I guess
he's really kind of shy.
I don't think I've met Preston, actually.
I'm not sure you have either.
No, I don't meet people in this business. I have not met Nancy Atkinson, which is just a total shame.
That's the funniest part.
Isn't that yeah. Nancy Atkinson, my senior editor, has been really helping with Universe Today for years and years and years, and I haven't even met her.
You video conferenced.
Oh yeah, no, we know each other virtually, but she stayed at your house one time for.
Yeah, she stayed at my house a couple of times, but she only lives a couple hours away from me, and she's come to see me give talks at the schools her kids went to.
Tetiana Vasilevska asked, what was the asteroid made of? We answered that. Nancy Graziano says, rolling on the floor, laughing my ass off. Now, Nancy is the moderator for the Astronomy Cast page on Facebook, and so she's the one who approves you or disapproves you from joining the group. So, Nancy, thank you so much.
Yes. And she wars on spammers.
Yes, we really appreciate all your help.
Thank you so much.
Josh Andrews says, the obvious way forward is to relabel all asteroids as either terrorists or immigrants. Terrorists, maybe.
Can you please tweet that so I can retweet it?
No, I will not, but I will put it into your...
Thank you.
That's pretty... Do you want to throw that in the chat here for you?
Yes.
All right.
That's brilliant.
Isn't that brilliant? All right. Done.
Can you put in the name of the person so I can attribute?
Don't! Josh Andrews.
Thank you.
I think. What's your... Josh, why don't you put... What's your Twitter handle, and then we can retweet it. I think it was Josh Andrews. It's already... My mind is... lost all this stuff. Lee Mitchell asks, and this was sort of back to the previous one, that if the Earth were to capture an asteroid as a second moon, how big would it have to be before it would have a noticeable effect on the tides?
That would depend on how distant its orbit was. Smaller things close to the Earth can have the exact same effect as bigger things further away.
Right, but close, inside the Roche limit, going to crash into the planet, so bad. But
inside the Roche limit, it's going to get torn apart by tidal forces.
But I mean, the thing is that these asteroids are going to be the mass of a mountain. If they're big, they're going to be the mass of a mountain, right? And the tidal effects of a big mountain on the other side of the Earth is not that big. So, Tom Nathy says, got to see a 1,000 piece of the Chelyabinsk meteorite. Fusion crust, chondrules, heavy. But $1,000, so there you go. That's a sort of idea. Okay, here you go. It's Josh Ertree is his Twitter handle. Let me just throw that into the chat. Thank you,
Thank you.
Josh. I put that up there. Moving on. Eric Wells says, have any meteorites been brought back from the moon?
I have no idea.
So yes. Well, okay, but hold on. Let's try and unpack what he's saying. So have any rocks been returned from the moon? Obviously, in the Apollo
Yes.
missions, they brought
But
back.
have any of those rocks have had their origin somewhere other than in the event that caused the formation of the moon?
Right. So did a
I don't
person?
know.
Yeah. Did any of the Apollo astronauts pick up a meteorite? Because I know that Opportunity or Spirit discovered a meteorite on the surface of Mars, right?
Yes.
I think it's happened more than once, but like a clearly an object of non-Martian origin sitting there on the surface of Mars. So, but did an astronaut find anything and bring it back? I don't know. I'm going to guess not, because that would have been pretty amazing. Although I'm sure they are all over the place on the moon, right? Because they're going to look very different from the surface of the moon, and they will not get worn down by the atmosphere or the water or any of that. So, great question. So Cecil Morgan asked, in the last segment, you said that the planet's orbits would be unaffected by the sun's collapse because the mass wouldn't change. But wouldn't the ejected material from the sun's collapse be dense enough to drag the planets into an inward spiral? So, okay, so let's imagine, right? We've got the sun, it puffs out as a red giant, and then it's like puffing out this envelope of material, and the planets are going to be plowing through that envelope, right? A bit. It's not going to be like right in the atmosphere of the sun, but there is going to be a certain amount of material they're going to be going through. That's going to act like a brake. Will that make them spiral inward?
Don't know.
Okay.
So well, I mean, it's an issue of we have combined forces at play. You have stuff hitting the planets, changing their masses, small factor. You have frictional drag, medium-sized factor. You have mass loss.
Right.
And how does the drag created by plowing through it counterbalance with the amount of mass that's being lost? People who've worked to model things like this have it currently working out that the Earth doesn't end up inside the sun.
Right. And so, as you say, there's too many forces. You've got the lost mass, so the planets are going to be moving further away. They're going to be plowing through some of this material, so there is going to be a bit of friction. We don't know. This is not your specialty.
Well,
Okay.
it's not just that, but it's the type of thing where we're still learning about mass loss rates.
Yeah. Yeah, I mean, there's some ideas that we might not even have a planetary nebula when the sun dies.
Right.
So, okay, so let's go back around to this question. So Lee Mitchell asked this earlier. If you could have any astronomer from history in a virtual star party, who would you choose? So I already said,
I
would
love
love to talk to Galileo.
Yeah, I think that would turn into a total Bill and Ted's Excellent Adventure, especially given the people that we have on the Star
Right.
Party. So, yeah, and if we could have two, because there's two of us and we're both being asked the question, I think having Galileo and Herschel, and if we can add a third person in, William Herschel and Carolyn Herschel both, because Carolyn Herschel was apparently a very tough as nails lady, and I would just love to have that kind of a music conductor in there with the trying to organize the chaos, and then the snipey soprano soloist who's a hard ass also in there with her knowledge, and I just that would.
But I love this idea. I mean, these poor people who
Didn't have the
discovered so much,
technology.
but they didn't have the technology, and so they could find this stuff, but they had no idea
It was
what
just
it is that they were
black and white,
looking at.
faint fuzzies.
Yeah, yeah. I mean, they were just looking in many cases with their eyes, ears on Saturn, like just not knowing.
Yeah.
And to be able to sit down and kind of go, let's look at it with better technology. That would be amazing.
Yeah.
So that's a great question. I love that question. Chris Kennedy's. Chris Kennedy says, any idea where the dinosaur-killing asteroid came from within our solar system? So 65 million years ago, the
Right.
one that hit Chicxulub, what do you think? Where did it come
Yeah.
from?
Um,
Was it an Apollo?
that's what I'm looking up.
Yeah. Chris Kennedy is one of the astronomers from the Virtual Star Party, and he lives in the UK. Man, this is great. This is just like a who's who of all our friends. There's Richard Drum. No idea? Still looking?
Still
Okay.
looking. Yeah,
Okay,
I don't know.
Let me dig some others up here.
Yeah, I'm not seeing information on that. I suspect that since we don't really have any fragments from it, we can't answer that question.
Nancy Graziano says, I would think that the fate of the solar system would also be in question due to our merging with Andromeda. Probably
No,
not, right?
so much.
Yeah.
Yeah, no. It's two ships passing in the night in the giant ocean.
So when that happens, the only stuff is going to be the dust piling up and forming new stars, but the rest of it will be fine. Thomas Traneker says, my work is done. Good night. In that I had to change my calendar over, so thank you, Thomas. You just don't forget, in a month, this is your job now. I will just leave it.
But now you realize all of us, it's like waiting to hear you say globular and about. There's certain things.
Globular.
Yeah.
Chin Chang Wu says there will be a website like Kickstarter for scientists where the public can back their projects.
Experiment.
That's what I heard. Yeah. Experiment. So that's a tough one, right?
Because so one of the problems is I actually looked very hard into putting a project up on that site when it was called Mycorrhiza. It's a great company. The two people who got it started are very easy and friendly to work with. But one of the things that you run into is they're trying to fund science projects through gifts and donations. And universities, when I write a grant to the federal government, for every $100,000 I get for my research, I have to get another $43,000 to give to my university to pay for the buildings, pay for the infrastructure, pay for the accountants, pay for all of those things. And that's called overhead. When you give to Astronomy Cast, when you give to CosmoQuest, 100% of that money goes directly to paying for my projects. There's no overhead that goes to the institution. So this falls into a gray area of it's a gift, but it's being allocated to do research. And Mycorrhiza, now called Experiment, doesn't allow you to ask for the overhead funding.
Right. Well,
and
if that's necessary, they will.
And so I know my university said, no, you can't use it.
Oh.
So, yeah.
Well, I mean, I think the problem with Experiment is that you've really got to just like be willing to donate your money to a scientific cause, and there's no, it's not like you in the end get a new bike lock or a Ouya. You are just pushing that progress forward, and so the whole process of demonstrating whether the experiment worked and the research papers coming out of it and stuff, that's going to be tough. But I think it's totally worth doing, and I'll bet you there will be some really interesting scientific studies that get pushed forward.
And honestly, once the first research project that costs more than a few $1,000s is funded, once the first research project that's a few $100,000 is funded, universities are going to start rethinking.
Mm-hmm.
But it is one of those things that a university does have to sit and think very hard, because especially the research that I do, it falls into two categories: research that involves lots of computer infrastructure, research that involves lots of students, and we're mapping out the surfaces of worlds, we're finding overlapping galaxies, and then my personal research into variable stars, although that keeps getting sidelined. But then I also do a lot of human subject research where I'm trying to understand, working with education researchers and psychologists, how do people learn, what are the connections between people that cause them to listen to podcasts. Research with human subjects requires monitoring. Otherwise, researchers will go off the deep end and do crazy shit.
And shady ethical,
Yeah,
moral, yeah.
and so I can understand why a university wants to get a certain percentage of the income to go to pay for all of that monitoring that's happening. And it's I don't know what the answer is.
Tatiana Vasilevska. This is your world.
I can't see this stuff.
Okay, Tatiana. I'm sorry, Tatiana. I'm gonna try. Here we go. Vasilevska. What puzzles me is why the asteroid was not detected. Don't we have enough technology for that? It came out of nowhere, right? It came out of the sun.
Well, the sky is an awful big place. And yeah, it came out of the direction of the sun. It came out of the east in the morning. And so you run into two problems. One is the sky is an awful big place. And so we have lots of surveys going on, but the surveys aren't looking towards the sun because it's towards the sun and you can't see anything but sky and sun when you look towards the sun. There's radar, but radar is extremely expensive. You can only look at a narrow beam of the sky, only detect things that are fairly close or very big. Pick one. So we focus the majority of our monitoring efforts on the band of the sky where you see the zodiac, the ecliptic in the sky. This is where the planets are. This is where the bulk of the asteroids are. And we're going to miss stuff, and we're going to get surprised by stuff. And this was one of those surprises. This is why we need surveys to systematically monitor the entirety of the sky. The Large Synoptic Survey Telescope is going to be the first one to map out, well, in its case, all the sky that's visible from its location in Chile. I think it's every 4 days, and it will do this for multiple years. So that will nail one large fraction of the sky, including the entirety of the zodiac. Ecliptic, different word.
Yeah.
But
well, I know that the Sentinel mission wants to be in like a trailing Earth trailing or Earth forward. So look at it. Essentially, look at the Earth from far enough away that you're seeing the stuff that Earth can't see because it's coming down the ecliptic. So that's that's a good way to go about it. Ranko Prozo says, aren't these events more common, but we don't see them because they explode over the oceans?
Yes, definitely.
Yes. Yeah, so there are probably impacts that we're just not seeing. Amazing meteorites, fireballs. Beyond a certain point, I think.
Well, no, we do
have
statistics on this from weather satellites and other Earth imaging satellites. There are a certain number of flashes every year. I don't remember the exact number, but it's order of tens of events each year that are getting detected. Flashes.
Okay.
In terms of these big impacts. The shock waves in the atmosphere get detected by this, that, and the other thing. So this probably was the first one that has occurred since we had massive monitoring equipment all across the globe.
Right. Okay, well, I think we probably want to hold there. Was there anything happening on the Twitters? Anything happening on the anywhere else?
The awesome quote. The obvious way forward is to relabel all the asteroids either terrorists or immigrants so that we can get money to search for them, is getting happily retweeted, and that pleases me because it's a quote that is true and it makes me laugh.
Yep. Hugo Burnham agrees that Caroline Herschel would be great to have in the virtual star party. And Hugo Burnham also notes that Preston debuted in Astronomy Cast 28.
Oh, that's true.
Wow.
Yeah.
Guido Bibra says that meteoroids will henceforth be referred to as Binsks around here. Hugo Burnham noticed our plug for Phil Plate's excellent book, Death from the Skies. Yes. Read Phil Plate's Death from the Skies.
Yes.
Richard Drum says you'll have to come to DragonCon and get your Binsk. So I will come to DragonCon this year.
Yay! I will be at Pensacon in Pensacola in a couple of weeks and at the Science Online conference the week after that. So if you're going to be at any of those things, drop me a note. We'll see each other. It will be awesome. I'll have a booth. We'll be selling stuff.
All right. So on this note, let's wrap this up. So once again, Pamela, thank you very much for doing this double bill. So glad that your voice has returned from its from the flu and that you're
Yeah.
feeling a lot better. Please try not to infect anyone else.
I can only apologize to @tinyintern for giving her my flu.
Yes.
But yes.
All right, and I will see you when I see you next. The next thing that's going to be happening, well, it's a couple of things. You guys are going to love this. I am the guest tonight on Billy Wilson's show at 7 o'clock to 10 o'clock, so 3 more hours of this. but I won't be sort of on. I will just hang out. Maybe I'll just nap, I think, while we do the show. So there's that. Yeah. Now, have you already? I think you're going to be on the show with him as well at some point. I saw.
Yeah, in a couple of weeks.
Yeah, I just thought I would just add it all together.
His show is just fun, and his cat is fascinating.
Yeah, and he has live musicians that come and stuff. So no, it's a real treat.
He's really figured it out.
Yeah. So Billy Wilson, check out his. You can just do a search for it. And yeah, I'll be there tonight from 7 till I don't know till I pass out. And so there's that tonight. Then we're going to be doing the virtual star party on Sunday night. So that's going to happen. And,
Noisy Astronomer will be there.
Yeah, which will be great. People have been chanting for Noisy's return. So if we can get her back, that'll be fantastic. So cool. Okay. Well, thanks again, Pamela. Thanks everyone for watching. We really appreciate it, and we will see you all not Monday, but the week after that. All right. Whoa. And people are already using it, so, it's all working. Okay. And people have been asking their questions again. That's great. Thank you very much, everybody. If someone could have any astronomer from history in the virtual star party, who would you choose? I would choose Galileo. Can you imagine showing Galileo stuff in the virtual star party? Like showing
it would turn into a total Bill and Ted's Excellent Adventure.
That would be so great. Great question, though. Wow. We'll answer that one again at the end of the show. Okay, so for those of you who just joined us, who maybe missed the first part of this, we are going to be recording a live episode of Astronomy Cast. This is going to be episode 334, Chelyabinsk, 1 year later. So we are recording this on February 7th, but this is the show that we would normally record on February 10th, Monday, and it would go live on our feed on February 17th, Monday, which is the closest we get to Chelyabinsk. So this is how we have to think into the future. We have to plan these things out like a careful orchestra of celestial. Were you tweeting again?
It's what I do.
I know, it is what you do.
I'm a Twitter girl. It's a problem. I love Google+, but Twitter...
Star Strider on Twitter with a Y.
With a Y. I should put up my lower third.
On Twitter.
Yes, you are.
You should put up your lower third. Yeah, who are you? Again, who is this person?
It's all a mystery. A mystery, I tell you.
So I guess the third and final act of our trilogy, Weekly Space Hangout, Astronomy Cast, ends in fiery death with the Chelyabinsk meteor. Actually, no fiery death because nobody died. Ends in exploding fireworks with the Chelyabinsk.
Fiery roof collapse.
Shattered glass, I guess, is how it ends.
There was a roof collapse.
Was there a roof collapse?
Mm-hmm. Mm. Not exactly fiery, more like, but.
Yeah. So once again, did I remember to click on the Q&A app? No.
Do we need to restart?
I did turn on the Q&A app.
Okay.
Hangout. So yeah. So it's a very high energy. I'm pretty jazzed up. Is there any other announcements? Anything interesting to talk about?
Just a reminder, we have all the apps. There's a 365 Days of Astronomy app. There's an Astronomy Cast app. There's a Universe Today Phases of the Moon app. There are Two, count them, two, but only available in Android, CosmoQuest apps. So if you want to support the shows and get something that you can go look and learn and have fun, go get apps, please. Please.
Go all the apps. Download
All
all
the
the apps. Cool. And then I just want to remind people that we're making our videos on Universe Today, and they're available now on iTunes. So if you want to download the videos and have them show up on your mobile device at the time of your choosing and watch them, you can go to universetoday.com/video or universetoday.com/audio, and you can subscribe, or you can get them on iTunes as well. Cool. Well, let's get rocking. So around this time last year, a space rock crashed into the Earth above Chelyabinsk, Russia. It brightened steel objects. So, can you tell I've had 4 cups of coffee and three shows?
That's all right. I apparently had like the best typo ever.
Did you?
Fergus Mason on Twitter points out that instead of writing Chelyabinsk, I wrote Chelyabink, which just leads to the idea of a meteor hitting and going bink.
Thomas, I have updated my calendar. That's what he was trying to get at. I didn't know what he was talking about. He's like, Fraser, it's February now. I'm like, what have I done? I have not updated my calendar. Look what's going on here in my year in space calendar. We've got Sarah Horst.
Oh, awesome.
Isn't that great? And we've
Sarah's a great human.
I know, and so this is great. The world of Titan. So, year in space, 2014 calendar for February. I am slow on the uptake today. So
it's okay.
Q&A app is on, so if you want to ask any questions, you can use the Q&A app. We will stick around at the end and answer some questions. I don't know how your time is. I'm
doing okay.
Okay. At some point I will have to be a parent, but, whatever. Lord of the Flies. Okay. I think I'm ready here. You ready there?
I know your children. It's more like Jungle Book.
Yeah. So say when.
I'm good. I'm pressing record.
I am also pressing record.
Hi, Preston.
Hello, Preston. Once again, we thank you for your dedication to Astronomy Cast. Here we go. Astronomy Cast, episode 334, Chelyabinsk, 1 year later. Welcome to Astronomy Cast, our weekly fact-based journey through the cosmos. We help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville, and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing?
Getting a little crazy, actually. Now that
you are over-caffeinated.
I am over-caffeinated. It's true.
I'm recovering from the flu, so we're a great pair today.
Right. Although it sounds like it's been week after week that you've been getting your Astronomy Cast just like normal, we're actually recording 2 of them today, just after we recorded the weekly space